How do synchronous versus asynchronous inputs affect flip-flop operation? Imagine you're trying to control a light switch in a busy room. Sometimes you want the light to change only at specific moments, and other times you want it to turn on immediately. This is similar to how flip-flops in digital circuits respond to different types of inputs. Flip-flops are like tiny memory cells that store one bit of information. They are essential in digital electronics for creating counters, registers, and other sequential logic devices. The way they react depends on whether their inputs are synchronous or asynchronous. Synchronous inputs are like signals that only act when a clock pulse arrives. Think of the clock as a conductor telling the flip-flop when to check its inputs. These inputs, which include signals like data, set, or reset, only influence the flip-flop at specific moments when the clock transitions from low to high or high to low. This means the flip-flop updates its stored value only at these precise times, making the operation predictable. Because of this, synchronous inputs are great for designing systems where timing and order are important, like counters or data registers. They requiring that the input signals be stable a little before and after the clock edge, which is called setup and hold time. If these times are not met, the flip-flop might not work correctly. On the other hand, asynchronous inputs can change the flip-flop state immediately, without waiting for the clock. These are like emergency switches that override normal operation. Common asynchronous inputs are preset and clear signals, which set or reset the flip-flop instantly when activated. This feature is useful for quickly initializing a system or resetting it during errors. However, because asynchronous inputs act immediately, they can cause problems if they change too close to a clock transition. This can lead to glitches or metastability, where the flip-flop's output becomes unpredictable for a moment. To prevent this, designers often add extra flip-flops to synchronize asynchronous signals, reducing the risk of errors. The impact of these inputs on flip-flop operation is significant. Synchronous inputs keep the data changes orderly and aligned with the clock, ensuring stable and reliable operation. Asynchronous inputs give immediate control, which is helpful for system resets or emergency stops but requiring careful timing to avoid errors. In complex systems, asynchronous signals are often synchronized with the clock to keep everything stable. Both types of inputs are vital in digital electronics. Synchronous inputs are used for normal data processing, while asynchronous inputs handle system initialization and emergency controls. Understanding how these inputs influence flip-flops helps in designing circuits that are both reliable and responsive.